This is part 2 of our lesson on logarithmic function review. This question says, simplify using log rules. So before we actually get to the question, I'm going to draw your attention to our reference package. On the page that says identity sheet, there are exponent laws and there are log rules listed there. So we have a couple of different log rules that we learned in advanced functions. The first one says that if we add two logs together that have the same base, we can combine them into one single log by multiplying the arguments together. The second rule says that if I am subtracting two logs with the same base, I can combine them into a single log by dividing their arguments. The third rule says if I have a log of something with an exponent and that exponent is on the entire argument, so not just one part but the whole argument, I can bring that exponent down and multiply it in front of the log. I will get the same answer. And then our third rule is change of base, which we used on the previous question, that says that you can change it to any base you like as long as you do log with your new base of the original argument divided by log with your new base of the old base. So we're going to take a look at the first question, question A. It says log base 6 of 4x minus 1 minus log base 6 of 2x squared minus 5x minus 3. So in looking at this question, I notice I have two logs and they are being subtracted. I also notice they have the same base, which means they are eligible to use log rules with. So when I am subtracting two logs with the same base, if I look at my yellow sheet, it tells me that I can combine them into one single log by dividing their arguments. So log base 6 of 4x squared minus 1 minus log base 6 of 2x squared minus 5x minus 3 would equal log base 6 of 4x squared minus 1 divided by 2x squared minus 5x minus 3. Now, when you have a log, you do need to always have a bracket around that argument if it is more than just one single number or one single variable. So since this has multiple numbers and variables, it needs to have a bracket around it. Now, we've already simplified, but I think that we could go further. So going further does not involve using more log rules. It involves using our factoring and reducing skills. I am going to look to see if we can factor 4x squared minus 1 and 2x squared minus 5x minus 3 to see if they have something in common that we could perhaps cancel out. So I'm going to take those off to the side. So I'm going to slide on over, and over in the margin, I'm going to factor those two things. Just looking for a different colored pen. All right, here we go. So 4x squared, take away 1, is a difference of squares. It has two terms, they are being subtracted, and they are both perfect squares. So this should be the square root of 4, which is 2, the square root of x squared, which is x, and the square root of 1, which is 1. I'm going to add in one bracket and then subtract in the other. Then I'm going to take 2x squared, take away 5x, minus 3. This has three terms, so my first option would be a common factor, which I don't have. And then the second one is to use perhaps decomposition. So I am looking for two numbers that multiply to negative 6 and add to that middle term of negative 5. So things that multiply to negative 6 would be 1 and 6 or 2 and 3. In order to get a negative 6 and a negative 5, I think it's going to have to be negative 6 and positive 1. Negative 6 times positive 1 would give me negative 6 and would add to negative 5. So this is going to be 2x squared, take away 6x, plus 1x, take away 3. I'm going to group together the first terms and the last set of terms. First pair has a 2 and an x in common, and I get x take away 3 left behind. And then the second one doesn't really have anything in common, so I'm going to say they have a 1 in common, and then x take away 3. I notice they both have an x take away 3, so I can common factor that out to say this is x take away 3 times 2x plus 1. So I'm going to replace the two things that we had with our new factored forms. So in place of the 4x squared minus 1, I'm going to put 2x plus 1, 2x minus 1. So I have log base 6 of 2x plus 1, 2x minus 1, divided by, and then x minus 3, 2x plus 1. And that needs a bracket around it to show that the entire thing is the argument for the log. Now, when I look at this, first I noticed that I missed a bracket, but when I look at this, I see that on the top and the bottom, I have a 2x plus 1. So since we are multiplying by 2x plus 1 on the top, and we are multiplying by 2x plus 1 on the bottom, when I multiply and divide by the same thing, they will cancel each other out. And we are just left with 2x minus 1 over x minus 3. So this is log base 6 of 2x minus 1 over x minus 3. Now, those did not need individual brackets, but they did need to have the big square brackets. So you could have just written big square bracket, 2x take away 1 without a bracket, and then x minus 3 without a bracket, as long as I have the big brackets around the log. All right, we cannot go any further than that. All right, our second one we are going to take a look at says 2 log base 4 of x to the 7 plus 5 log base 4 of x to the 6. So first thing I notice when I look at the question is they do have the same base, which means it is eligible for us to use log rules. We do have a rule for addition that says when I am adding two logs with the same base, I can multiply their arguments. However, there is a little bit of a problem here, and that is that we have coefficients in front of the logs. So if you have a coefficient in front of your log, you cannot combine them into a single log unless it's the same coefficient for both. So since this has a 2 and this has a 5, I cannot currently put these together with the log rule. If I think about order of operations says you have to multiply, which is what we're doing here, before we're allowed to add. So we are going to use the rule that says log base b of x to the n equals n times log base b of x, except we're going to use the rule going backwards. We currently have a number being multiplied out front, so we are going to bring it up and make it an exponent on our argument. So this is going to become log base 4 of x to the 7 to the power of 2, right? We're bringing this up as an exponent on our argument. And then this, the second one, is going to become log base 4 of x to the 6, and then bring that 5 up to the power of 5. Now on my sheet, I do have some exponent laws. So there is an exponent law here that says b to the x to the y equals b to the x times y. So when we have a power on a power, we multiply those two powers together. So this would end up equaling log base 4 of x to the power of 7 times 2, which is 14, and then plus log base 4 of x to the 6 to the 5. I multiply those. 6 times 5 is 30. So I get x to the power of 30. The last thing that I can do is I can combine those two logs together now that they don't have any coefficients and they do have the same base by multiplying their arguments together. So this is going to become log base 4 of x to the 14 times x to the power of 30. Now when I multiply powers together on my sheet, it says when I multiply two powers with the same base, I can add their exponents. So these definitely have the same base. They both have a base of x, so I can add together those exponents. So 14 plus 30 is 44. So I have log base 4 of x to the power of 44. And that is a great final answer. However, if you wanted, you could use the rule that we started with, and you could go one step further and bring that 44 down and say that this is the same as 44 times log base 4 of x. Either one of those answers is perfectly acceptable. It is up to you which one you want to use. All right, I will see you in part 3 of the video to do the last part of the questions.